My name is Munther Dahleh, and I'm a professor of electrical engineering and computer science. Also, I am the director of the Institute for Data Systems and Society. The Institute for Data Systems and Society is focused on taking rigorous and analytical approaches for solving complex societal problems. And in our definition, societal problems or challenges are ones where the society is an integral part of the loop, is part of the application, is part of the problem, and ways in which we can figure out using the data to developing models, to developing decisions about these kinds of systems will be the drivers for this particular institute and the effort in the institute. From my perspective, societal problems are many problems where the society is part of the issue. So, for example, if you think about infrastructure questions in terms of transportation problems, right now, with the tools from Google Maps and Waze and so forth, you find that the drivers are an integral part of the application, which is in this particular case transportation. It's the same thing. The same thing is happening in the case of the power grid, energy consumption, the financial system, where the high velocity trading allows individual creditors like myself to be engaged with the market in real time. And with the large number of people like us responding to signals from the markets or signals from the streets and so forth, we are directly impacting the outcome of a lot of these applications. So we would like to develop analytical methods for understanding the integration of society into these kinds of applications. We think of ourselves in IDSS as following rigorous approaches from data to models to decisions to answer these fundamental challenging questions about efficiency, risk, sustainability, and so forth. So, for example, let's think about the problem of the power grid in a little bit more detail. So this probably is one of the most complex engineering systems that have been built. It has multiple components between generation, transmission, distribution, and then, of course, us people who are consuming the electricity. It has a very severe constraint on it in that demand and supply have to be equal to each other all the time. Today, the power grid is also getting upgraded to include renewable resources, which are more stochastic in nature. There's more variability if you're depending on wind or depending on solar energy to generate electricity. There's also, with the implementation of smart metering, consumers will be in the future able to change their demand depending on the price of electricity at any given time. So that increases the variability of the demand as well. And if you think about this application, in the middle of everything, there are actually markets where electricity is being bought and sold. And these markets exist at 2 hours and they exist at 5 minutes. And so you've got an engineering system, you've got markets in the middle of it, and then you've got people at the end who are consuming electricity. And you look at that system and you say, okay, what we want to be able to do is 24/7 provide electricity to everybody that demands it without any outages and at a reasonable price. And the question is, how are we going to do this? We've been doing it for many years, and even though we think actually that we've been improving the grid, the number of outages and the cost of outages has been exponentially increasing over the past decade. For various reasons, we can talk about that. The grid is getting more and more stressed because of the need for electricity, particularly as we have higher penetration of electric cars and so forth. And so now the issue is, can we continue to provide electricity without outages? Can we assess the risk of the power grid? And what do the models look like? How do we develop models and control strategies to do this? When we are talking about engineering system, we're talking about a social system in terms of the consumer, we're talking about the economic system in terms of the markets, and we're still talking about the regulation of the overall system. So you can imagine the complexity of this interconnection, and what we're looking for is ways in which we can simplify and address this question in a systematic way.